Good day, viewers. You are welcome to today's teaching. In today's teaching, we'll be looking at circle geometry. Circle geometry. We're looking at geometry in circle. Now we have a circle here. This line AB. This line AB is what we call the chord. While from here to here is an arc. And everything here, when we have it like this, we call it a segment. A segment. Then here, this line is the diameter. The diameter that divides, that is the center of the circle. Then here we have this length is the radius. The radius. From center to the radius. Again, we have this as the chord. This AB is equal to chord, and we have our arc here. Then we also have the diameter at the center. Then we have a radius. So we are going to look at different theorems in this topic, and that is what we call circle geometry theorem. Here is the first theorem. Theorem 1 says that angle subtends at the center is twice the angle subtends at the circumference. This is the circumference, and this is the center O here. Here we have center O. At this center, that means that from this it means that x is equal to twice 2 times x. Angle subtends at the center is twice the angle. The meaning is angle subtends at the center is twice that of the circumference. So that is interpretation. Now angle subtends at the center. To get the circumference, to get s, whatever you have here, multiply by 2. You multiply by 2. Whatever you have here, you multiply by 2. And to get this one back, what do you do? What do? You divide by 2. So angle subtends at the center is twice angle of the circumference. If this place is 50, for example, that means that angle at the center will be 100. 2 multiplied by 50 will give us 100. And if this one is 100, that means we divide by 2. This place is going to give us 50. Therefore, angle subtends at the center is twice an angle of the circumference. Now, the second theorem states that angles in the same segment of a circle are equal. Angles in the same segment of a circle are equal. The same segment. That is, we have the first segment A, P, B. That means that the same angle is equivalent also to A, Q, B. So that means that x1 is equal to x2. x1 is equal to x2. So angles in the same segment of a circle are equal. Here, the third theorem is opposite angles of a cyclic quadrilateral are supplementary. If they are supplementary, that means they add up to 180 degrees. That is, they add up to they add up to 180 degrees. Now, when we have cyclic quadrilateral quadrilateral is having 4 vertices. when the four vertices touch the the circumference, here we have 1, 2, 3, and 4, touching the circle at 4 different places. So that is what we call cyclic quadrilateral. So this is cyclic quadrilateral. And what is the interpretation? The interpretation is x plus y, that is opposite angles is equal to 180 degree. They are supplementary. Then p plus q is equal to 180 degree. They are opposite angles. And because they are opposite angles, but they are also quadrilateral inside the cycle, they are supplementary. They are supplementary in that they add up to 180 degree. Here is another theorem, theorem 4. This one is the corollary to theorem 3, where we have opposite angles of cyclic quadrilateral that are supplementary. So here, when one side of a cyclic quadrilateral is produced, the exterior angle formed is equal to the interior opposite angle. Let me take that one again. When one side of a cyclic quadrilateral is produced, the exterior angle formed is equal to the interior opposite angle. Now, this is the cyclic because we have the 4 vertices touching the circle. Now, this is the line produced, the exterior line produced. Remember that A and C, they are equal to 180 from theorem 3. That says that opposite angles of a cyclic quadrilateral are supplementary. So they add up to 180 degree. Then C plus E now. This C and E. Remember that this is angle on a straight line. Angle on a straight line. That is C plus E. And angle on a straight line will add up to 180 degree. The sum of angle on a straight line is equal to 180 degree. Therefore, A plus C, that is this A plus this C, is equal to C plus E. Therefore, A is also equal to E. A is equal to E. Now, to cap it up is that angle BAD is equal to angle DCE. Angle BAD is equal to angle DCE. Here is a typical example, and this one will follow theorem 1. Here we have to find the value of x. In this diagram, we have to find the value of x. Here we look at it as angle at the center. In theorem 1 says that angle subtended at the center is twice an angle at the circumference. Here we have to find x. That is angle at the circumference. But here we don't have angle at the center yet, but we have a reflex angle. So angle AOC is a reflex angle. Angle AOC, that is a reflex angle. Angle AOC is a reflex angle. So that means that angle AOC is equal to 360 minus 146. And that is, you can call it angle at a point. Sum of angle at a point. Sum of angle at a point. So that means that angle AOC is equal to 360 minus 146. Let's work it out. That will be 360 we want to subtract 146 from it. So we have 1, that will be 4. That is 1. That will be 2. Is equal to 214. So that means that the reflex angle AOC is equal to 214. But that is not what we are looking for. That means that this O now, our angle O here is 214. Then remember, according to the theorem, that means that AOC, angle AOC, which is 214, is equal to 2x. Why? Is equal to 2x. That is, angle at the center is twice angle at the circumference. So that means that angle at the center is twice angle at the circumference. So that means we're having 214 equals to 2x. We divide both sides by 2 to get our x. Divide both sides by 2. Here 1, here 1. So that means our x is equal to 2, here 1. 2 in 214 is 107. So x is equal to 107. So the answer to this question is x here is 107. And if it is this side that you are looking for, that means it will be twice the angle at the circumference. So this place will now give us 214. Here is another question. In this diagram, we have to find the angles marked by letters P, Q, and R in the diagram above. If x is equal to 54 degrees, that is this angle, and W and this angle is equal to 30 degrees. So which theorem are we using? We are using the second theorem, that is theorem 2. And what does theorem 2 say? It states that the opposite, that is angles in the same segment, they are equal. Angles in the same segment, they are equal. This is the first segment, that is APQ is the first segment, while the second one is AQB. So angle in the same segment, they are what? They are equal. So that means that x, from that question, say x is equal to 54, and W is equal to 30 degrees. And you know that PQ is equal to x. And what is? That is angle in the same segment. And that means that Q is equal to 54. P is equal to W. The same reason in the second segment. Angle in the same segment are the same. They are the same. Angle in the same segment. So that means that if W is 30, that means that P is also equal to 30 degrees. But we have to find the angle, we have to find letter, we have found PQ, then it remains R. How do we get R? So when you look at the diagram to the center, that means that what we have here is a triangle. We are having a triangle here. That means that if we are having a triangle, that means that P plus Q plus R is equal to 180 degrees. And what is the reason? Sum of angle in a triangle. Sum of angles in a triangle. That means that we are going to have it as, what is P? P is 30 plus, what is our Q? Plus 54 plus R equals to 180 degrees. So that means that R, 30 plus 54 will give us 84 plus r equals to 180 degree. So that means that our r is equal to 180 degree minus 84. So our r will give us 180 minus 84. That is, subtract 84 from 180. That means we are going to have 96 degree. Therefore, our P is equal to 30 degree. Our Q is equal to 54 degree. And our R is equal to 96 degree. Here is another example. And when you look at this, you discover that this is a cyclic quadrilateral. I told you the other time that when the four vertices touches the cycle, well, the first one, the second vertex, the third one, and the fourth one. That shows it is what? A cyclic quadrilateral. That is quadrilateral inside cycle. And what is the theorem? The theorem says that opposite angle of a cyclic quadrilateral are supplementary. Opposite angle of a cyclic quadrilateral are supplementary. And what is the meaning of that supplementary? It means that they add up to 180 degree. They add up to 180 degree. So that means that if you are looking at opposite angle, which one? X is opposite to 120 degree. 88 is opposite to Y. So that means that X plus 120 degree is equal to 180 degree. Why? What is the reason? Opposite angle in a cyclic quadrilateral. So that means that we are going to have that x is equal to 180 minus 120. So our x will give us 60 degree. Then the next one is to find y. The same thing, y plus 88 is equal to 180 degree. And what is the reason? Opposite angle in a cyclic quadrilateral. So that means that our y is equal to 180 degree minus 88. So y is equal to 180 minus 88. That means we are having 180, 880. It's impossible to put 2 here. So 8 from 17, we have it as 9. So our y is equal to 92 degree. So that is the value of x and y in this diagram. That is the value of x and y. At the end of this video, an assignment will be given. In our next video, solution to the assignment will be provided. Do well to watch the next video.